Our next lesson is called Piecewise Functions Day 2. I'd like you to complete the opening exercise that says graph the following functions if the domain of the graphs is all real numbers. You're going to graph f of x, g of x, and h of x, and then answer the follow-up question, what characteristic makes the function h of x different than f of x and g of x? So at this time, pause the video and resume when you are ready to go over the answers. So you've completed the opening exercise. Take a look at your pictures. For each one of these, they were in mx plus b form. So you will see for f of x and g of x and even h of x, I put the slope and the y-intercept. You must show some type of work in order for your graphing to count. You either need to write down m or b like you see I did here, or you need to go to your graphing calculator, type it in the y equals screen, and get the table of values and write down a table of values similar to what I did in the graph for h of x. So you plot your y-intercept first, and you use your slope to get the rest of your points. So for the follow-up question, what characteristic makes the function h of x different than f of x and g of x? H of x is a horizontal line with a slope of 0. So it's the only one that is not slanted in any way, has a slope of 0, therefore creates a horizontal line. A quick note about that, you can see I have the m and the b, but remember what we said about these. You can just make a table of values and autofill. You also have your graphing calculator that can help you with this because remember h of x is really in place of a y. So that's really y equals 5. So you can use your graphing calculator to help you with that. All right, let's look at example 1 on step functions. So this is a new type of piecewise function that we need to show you so that you're aware of what it looks like and how it works. Step functions are a piecewise function with many subfunctions that resemble stair steps. So that's where it gets its name from. It looks like stairs. The following graph represents the age a soccer player can be versus their division. The function rule for this graph would be as follows. So this is how you would want to write this. Remember that f of x is really replacing y. So when you have a horizontal line like you did up here, you had y equal to a number, and that number was where the horizontal line was crossing the y-axis. So if I was looking at this graph, the first section, if I were to extend it, okay, I'm not going to leave it like that, but just so you see, it would cross the y-axis at 1. So I'm going to give my squiggle bracket, and the first equation should be 1, f of x equals 1. We are using that from 5 to 7, but you can see there's an open circle on 5, so 5 would not be included, and there is a closed circle on 7, so 7 would be included. So this would be for 5 is less than x is less than or equal to 7. The next step, if I were to extend this, would cross the y-axis at 2. So I would put 2. And I'm going to use that from 7 to 9. 7 has an open circle, so it's not included. 9 has a closed circle, so it would be included. So 7 less than x less than or equal to 9. And that way it follows the pattern we talked about before, where if 7 is already counted, we cannot count it in 2 different places. And it continues like this. The next one crosses at 3. We need to go from 9 less than or x less than or equal to 11. Then our next one would cross at 4, so f of x equals 4. That's from 11 less than x less than or equal to 13. And then our last section would be 5, going from 13 is less than x is less than or equal to 15. In example 2, it says model the following description with a step function. You want to bring cupcakes to math club to celebrate your birthday. Each box of cupcakes contains 6 cupcakes and costs $4. You expect as many as 30 students to be at math club. Create a function that models the cost in terms of the number of students in math club. Okay, so this time we're writing a function from scratch. Nothing has really been defined. In the question before, it was defined because age was on the x-axis and division was on the y or f of x axis. Here we do need a let statement. So we'll let x equal the number of cupcakes, and then c of x would equal the cost of the cupcakes. Now, if the cupcakes are having 6 in a package, this part right here is telling us our domain. okay? So remember, C of X is the cost. So C of X equals, the cost is equal to, and we want to think about it as in boxes of cupcakes. So there are 6 cupcakes in one box. If I purchase one box, that's going to be $4. So that's the first part of my function. The cost is $4. Now, when we go to write our domain, we're using the number of cupcakes inside the box, not the number of boxes, based on the way we set up our let statement that X is the number of cupcakes. So one box costs $4, but there are 6 cupcakes in there. So we're going to go from 0 less than or equal, so we're going to go from 0, which is less than X, which is less than or equal to 6. Now, we're not including zero because in context of the problem, you wouldn't be buying any if there was no cupcakes in there. Okay, so 0 is not included. Then if I were to purchase a second box of cupcakes at $4 a piece, that would be $8. And that would be if I went from 6 less than X less than or equal to 12 cupcakes. So we already paid for the first 6. Now this is for the second 6 cupcakes. 6 was already included in the previous part, so we do not include it here. And this pattern is going to continue. Another $4 would be 12 for cupcakes from 12 less than or X less than or equal to 18. Then we would have $16 for cupcakes from 18 less than X less than or equal to 24. And then remember, we might have as many as 30 students, so we need to go one more time. Another $4 for cupcakes from 24 less than or X less than or equal to 30. Then I know I'll have enough for math club. So there's the piecewise function that represents that situation. In example 3, graphing piecewise functions. The table below lists the total cost for parking for a period of time on a street in Albany, New York. The cost is for any length of time up to and including the hours parked. For example, parking up to and including an hour would cost $1.25. Parking for 3.5 hours would cost $5.75. So you're going to graph the step function that represents the cost of the number of hours parked. So we have the table over here on the left. Hours parked, 1 would cost $1.25. Up to including 2 would be $2.50. So that's where they're trying to say to you up to and including. So when we see parked for 1 hour, you can actually park for less than an hour, but you still have to pay that $1.25. Okay, so now we're going to create the graph for this. We've got 1 at 125. So 125 is right here. Now remember, you're paying $1.25 for up to and including 1 hour. That means if you park for anything over 0, all the way up to and including 1 hour, you're paying that amount. So we're going to put an open circle on 0, 1.25, and a horizontal line to show that. Then we jump up to the next interval, which is 250. So if I go find 250, I need to put an open circle here because 1 has already been included in the previous step. And as soon as I get just over 1 hour, I'm going to be paying $2.50 for up to and including 2 hours. So you can see our steps starting to form. The next jump is to $4. So we are going to put an open circle on 2.4 because we already know that if we park for 2 hours, we're still paying $2.50. As soon as I go over 2 hours in the slightest, I have to jump up to $4, and that's going to be $4 up to and including 3 hours. And we continue with this pattern. The next one is $5.75. Up to and including 4 hours. Then $7.75. Up to and including 5 hours. And then we have $10 up to and including 6. So there are all of our steps that represent this parking situation. So now I'd like you to try the practice questions, which is practice with piecewise functions. Write a piecewise function that describes the graph. I do want to add a couple of details for you. I'd like you to add arrows. I know there is an arrow there, but it's very hard to see. It's very small. There should be arrows on both sides of that first graph. And then just to make them again larger, they are in the picture but not very big. There should be an arrow there, an arrow here, and everything else is very clear. So at this time, pause the video, try the practice problems, and then resume when you're ready to go over the answers. So in practice A, there are two pieces. I'm going to call this f of x. In the first piece, I'll pick 2 points on the line to find the slope, which is up 2 to the right 1, which means I have a slope of 2. So 2 is going to go in front of the x. When I look to see where it crosses the y-axis, it's crossing at 4. So plus 4. And we are going to use that from x is 0 and to the left of that. So x is less than or equal to 0. Now that was a closed-in circle, so I'm going to include it there, and I just won't include it in my next interval. The second piece is what we've practiced today. It's got a horizontal line. So that would be the line y equals, it's crossing the y-axis at 4. So y equals 4, but the y would get replaced with f of x. So we're just going to put the number 4 like we did for our step pieces. And we're going to use this for x is greater than 0. 0 was already included. In question B, we've got 3 pieces. The first piece, if I were to extend it, you can see it's going to cross the y-axis at -3. So I'll call this one g of x. Remember, it doesn't matter. We know we're going to have it at -3. And we are using that from this cutoff, which is x equals -2 and down. But notice there's an open circle, so that 2 is not included. So x is less than -2. The second portion, if we find the slope, we're going up 1 to the right 1, which means we have a slope of 1. So 1 is going in front of x, which means you can just write x. When I look at the y-intercept, it's 0, so no need to write plus 0, but you can if you want. And we are using that from x is -2 up to x is +2, both included because of the closed circles. So -2 is less than or equal to x is less than or equal to 2. And then in the last section, if I were to extend this, you can see that it would cross there at +4. So this is g of x equals 4. We are going to use that from 2, not included because of the open circle and the fact that we already included it. So we're going to use that from 2 and up. So for x is greater than 2. And that concludes your lesson on piecewise functions, day 2.